Hey everybody, welcome back to another Science Saturday. I know it's been a couple of weeks and I do apologize. Things have been absolutely crazy. Oop, I think my phone's sliding. Things have been absolutely crazy between just impromptu traveling that I've been having to do and a lot of MCAT studying. So please remember me in your prayers. But I am back today with a really sweet experiment that I'm super excited to show you all. So today we will be analyzing how matter changes with ice cream. And so I'm going to go ahead and explain it, and then we'll start cooking up our ice cream in a bag. So of course ice cream is a solid, liquid, and gas all in one, and I'm just going to flip over and show you something I drew to show the states of matter. And so here we have a gas, and as you see the molecules are very spread out. And here's like my little thermometer over here. So gases are typically hot. So like think about the steam that comes off of your shower. And then we have liquid, which is another state of matter. And these molecules are still spread out. They're a little bit closer together. And this is kind of an in-between phase. So think about how you can have like hot tea or iced tea. So it can really go either way. And then we have solid. So of course I drew an ice cube, so you can think of an ice cube, and those are typically cooler. Sorry, there's like a ton of computer stuff back there I just showed y'all. But let's get started making our ice cream, and let's see how our ice cream turns into its combination. It turns into a compound, so it has a little bit of all of those states of matter. So I have my material list right here, and we're gonna start. In this bowl I have 2 tablespoons of sugar, and I'll actually go ahead and scroll down here and show y'all the chemical makeup of the sugar. So this is sucrose, and that is what it looks like. These right here are carbons, hydrogens, and this is an oxygen and a hydrogen, and we call that an alcohol. So that is what makes up our sugar. So we have 2 tablespoons of that. Let me scroll back to my materials, and we're gonna add, sliding again, I apologize for the technical difficulties. Then I'm gonna add 1 cup of half and half. And this is our fat in our ice cream, and I am going to show you fat molecules in a second. So 1 cup of half and half. One thing in lab that chemistry professors are very particular about is your measurements. And a lot of people don't typically think of cooking as chemistry, but that's exactly what it is. And that is why when I cook, I'm very particular about how I follow my recipes. So I'm just gonna mix this together. I'm gonna show y'all a picture of fat molecules real quick. Scrolling through. Okay, so fat globules, are made up of glycerol and palmitic acid, and this is a picture of glycerol. Like I said, we have the alcohol groups, the carbons, and the hydrogens, and this is palmitic acid, which is a polymer. Okay, so we added the half and half and the sugar, and we're gonna have vanilla ice cream today. So we're going to add, let's see, I think it's a half a teaspoon of vanilla extract. I wish this would stop sliding. Okay. So we added our vanilla extract, and I will show you a picture of the composition of vanilla, which is, sorry, that's my forehead, right here. And this is what we call an aromatic ring. You see how it's the carbons and that one oxygen are all in a ring? That is an aromatic ring, and it's rightfully named because vanilla is very aromatic and it smells great. And a lot of the things that smell really great, oils and stuff like that, have those aromatic rings. There are some things that smell really terrible that have aromatic rings too, but it's cool how the chemical composition is named for the smell, basically. So I'm going to mix this all together. I don't know if y'all can hear all the sugar in the bottom. And let me know if I can adjust the camera for y'all to see better. And I'm having some technical difficulties today. Ooh. Okay. Now. Okay, let me see if I can find something to hold this up. Maybe this will work. Hopefully. Now I'm going to pour this into a sandwich bag. So hopefully I can do this without getting it all over me. Gotta make sure to get all the sugar in here. Okay, I think I got all the sugar in here, I hope so. And I'm just gonna seal this really, really tight. There we go. Okay, next, I have a gallon Ziploc bag, and I put 3 cups of ice. You can put a little bit more if you're gonna do a couple of bags of ice cream. If you have multiple little scientists who wanna do multiple things of ice cream, just you can use the same bag. And so 3 cups of ice right here, and I'm gonna add 1/3 of a cup of kosher salt or rock salt. I'm using kosher salt because it was easy to get from Walmart. I'm just gonna pour it all over that. And so the salt added to this ice lowers the ice's melting point, like we talked in the States of Matter. And so that's the point where this ice turns into a liquid. And this ice wants to do that, so it has to still heat and absorb it from its surroundings. And in this case, its surroundings is our ice cream mixture we just put in here. So we're going to shake this up for 7 to 10 minutes, and we are going to let the ice steal away some heat from this ice cream mixture and make our ice cream. But before we do that, I'm going to show you the chemical composition of ice cream as a whole. And so here's my little picture of ice cream that I drew. And here is what we just made. In it, we have our ice crystals. Those will form as we shake it and they freeze. We have air, of course, all around it. So, I mean, that's solid and gas right there. And then the liquid would be our liquid syrup, which in this case will be our vanilla. And then we have our fat globules. So ice cream is a compound. Ingredients are chemically combined and they cannot be separated physically. In order to separate them, we would have to have another chemical reaction, and it would be very difficult to separate them. So I'm going to shake this bag up. We're going to see it become ice cream, and I'm going to taste it too. I'm excited. And I'm not going to make you watch me shake this bag for 7 minutes. Every couple of minutes I'll pull it out and we'll see how the ice cream is changing its state of matter. This is really cold, by the way, if you want to wear gloves or something. Okay, I'm going to go ahead and pull this out real quick and see. Might be spilling a little bit. Still a liquid, but it's getting a little, I can see bubbles moving, so that's exciting. Oh, technical difficulties, back at it again. I thought I had something balancing it. Ooh. I really should probably invest in a cameraman or something, or maybe ask my mom to help out next time. But I think we are getting somewhere with our ice cream. This is freezing my hands. So, learn from our mistakes and definitely go ahead and use some gloves. This is not done all the way, but it's got some ice crystals forming in here. So this would be some super soft served ice cream, but it smells really good. My hands are about to freeze. So I'm going to continue to shake this off camera. I'm going to go grab some paper towels, and I will post a picture or a video of what the ice cream looks like and what it tastes like, and I'll give you a full review. I did not realize how cold it would be, so I don't want y'all to have to watch me give myself frostbite. My hands are turning a little bit red. Frostbite on Facebook Live. So I will be back in a second with the results of our ice cream.